Good morning. This is Rajashekar Reddy, Assistant Professor of Mathematics, Government First Grade College, Pavagada. In third semester BCA, we have numerical analysis. In this chapter, we can measure the solutions of algebraic equations. For any given algebraic equation, we can find the roots. In the previous class, we learnt about direct methods and iterative methods. In the iterative methods, the first method is bisection method, that is successive bisection method. So in this method, if you want to find a real root of f of x is equals to 0, first we assume the root lie between an interval x0 to x1 such that f of x0 into f of x1 is less than 0. If the condition satisfies f of x0 into f of x1 is less than 0, then we measure x2. x2 be the midpoint bisection. That means we measure midpoint of the interval what we selected. x2 be the midpoint of the interval x0 comma x1. So here x2 we calculated by taking x0 plus x1 divided by 2. So in this case, the root may lie between one of the two half intervals, either x0 to x2 or x2 to x1. Suppose the root lies between x0 to x2, then f of x0 into f of x2 is less than 0. If f of x0 into f of x2 is less than 0, we say the root lies between x0 to x2. So in this one, in iterative method, again we find the midpoint of the interval x0 comma x2. Say that one is x3. So x3 we can get by using x0 plus x2 divided by 2. Again, whether the root lies between x0 to x3 or x3 to x1, we can measure in the same process by finding f of x0 into f of x3 is less than 0 or greater than 0. If it is less than 0, we say the root lies between in such particular interval. The same process we repeat till the desired accuracy is obtained. For example, if you take an equation x cube minus 9x plus 1 is equals to 0, and they given that the root lies between 2 and 4. So here first we choose x0 is equals to 2 and x1 is equals to 4. F of x is equals to given polynomial equation x cube minus 9x plus 1 is equals to 0. First we measure f of x0, that is f of 2, that is minus 9, which is less than 0. Next we measure f of x1, that is f of 4, that is 29 greater than 0. Product of these two functional values, f of x0 into f of x1, that is less than 0. That's why we say the root lies in between 2 and 4. In the first iteration, we take x2. So that is equals to x0 plus x1 divided by 2. That is equals to 2 plus 4 divided by 2 is equals to 3. And we measure functional value f of x2 is equals to f of 3. That is equals to 1, which is greater than 0. Already we know f of x0 value is less than 0. Hence f of x0 into f of x2 is less than 0. So we can say the root lies in between 2 and 3. The root lies in between 2 and 3. Again in this method we measure x3, that is equals to x0 plus x2 divided by 2, that is 2 plus 3 by 2, that is 2.5. So we measure f of 2.5 value, that is minus 5.875, that is less than 0. In the previous section in 2 and here we got less than. So already we calculated f of 2 and f of 3. In that one we choose the greater than quantity. We know already f of 3 is greater than 0. That's why f of x2 into f of x3, if you multiply these two, we get it is less than 0. Hence we say real root lies in between 2.5 and 3. Then in iterative method again we go for a root x4, that is x2 plus x3 divided by 2, that is equals to 2.5 plus 3 by 2, it is 2.75. Now we measure f of x4, f of 2.75, that is equals to minus 2.9531, which is less than 0. In the previous calculations we got f of 2.5 is less than 0. Here also less than 0. Product cannot be less than 0. That's why we select f of 3, that is greater than 0. Hence f of x4 into f of x2, multiplying you get less than 0. So we can say, based on this we can say the root lies between 2.75 and 3. Again we go for in iterative method other root x5, that is x4 plus x2 by 2 is 2.75 plus 3 by 2 is equals to 2.875. We measure f of 2.875, that is minus quantity, which is less than 0. In the previous calculations we choose the first positive quantity. The positive quantity is f of 3 greater than 0. So f of 3 greater than 0, and here f of 2.875 is less than 0. So we can say the root lies in between 2.875 and 3. So in the iterative method again we go for a root, that is x6, that is equals to x5 plus x2 by 2 is nothing but 2.875 plus 3 whole divided by 2 is nothing but 2.9375. So at that value again we measure the functional value, which is a negative quantity less than 0. In the previous calculations already we know the positive quantity is f of 3 greater than 0. Multiplying these two, f of x6 and f of x2, which is less than 0. Hence what we can conclude, the root lies in between 2.9375 and 3. Then we go for x7, again another root, 2.9375 plus 3 whole divided by 2, that is 2.96875. f of 2.96875 is nothing but a positive quantity, 2.44 greater than 0. So in the previous calculations we choose negative quantity, that is f of 2.9375. So we can say the root lies in between 2.9375 and 2.96875. So one positive function value select ಮಾಡ್ಕೊಂತೀವಿ, ಇನ್ನೊಂದು negative function value select ಮಾಡ್ಕೊಂತೀವಿ. Why? Because product of the two makes less than 0. Hence only we can say the root lies in between such two interval. Then go for other root x8, that is x6 plus x7 by 2, that means 2.9375 plus 2.96875 whole divided by 2 is nothing but 2.953125. f of x8 you get 0.175922. So f of x6 and f of x8 is less than 0. Again we can say the root lies in between 2.9375 and 2.953125. So like that we can repeat the same process till the desired accuracy, means approximately the root closer, approximately the iterative root if you find, so that will be closer. So here root lies between 2.93 and 2.95. So we can say the approximate value of the root, again we find the average of these two, we get 2.94. This 2.94 is closer to 2.93 and 2.95. Hence we can stop the process and we can say the approximate root of the given equation is 2.94. Like that, we can find the approximations using the iterative method under this bisection method.